February 2021, Texas. A winter storm hits that no one saw coming. Temperatures drop to minus 18 degrees Celsius, levels this state had not seen in 70 years. Within 48 hours, 14 million people lose running water. Pipes are bursting inside walls, inside attics, inside mobile homes and million-dollar houses alike. The sound, that sudden crack followed by the rush of water behind drywall, becomes the most terrifying sound in the state. Plumbers are charging $1,200 for a single house call. Some are not showing up at all. Hardware stores run out of pipe repair tape in 3 hours. People are standing in line at dawn for bottled water. Social media is flooded with desperate posts. Anyone know a plumber? Anyone? Please. And then something strange starts happening. In neighborhoods across San Antonio, Dallas, Fort Worth, older residents, mostly grandmothers, mostly women in their 70s and 80s, start walking next door. Calmly. No panic. They are carrying 2 things, a box of baking soda and a bottle of white vinegar. Combined cost, less than 40 cents. While their neighbors are spending $1,000 waiting for a plumber who never comes, these women are clearing pipes, restoring flow, and preventing freeze damage buildup using a method they learned from their own mothers. A method that predates the entire plumbing industry by 2,000 years. And every person who watched it happen had the same thought. Wait, if the solution was that simple, why didn't I know? That question is exactly why we are here today. So ask yourself honestly, when was the last time a plumber told you not to call them? When was the last time a hardware store pointed you toward the baking soda aisle instead of the chemical drain cleaner shelf? When was the last time anyone, a contractor, a landlord, a home improvement show, told you that the most effective drain maintenance system ever documented costs under $11 a year? They didn't. And that silence has a reason. We will get to it. But first, where did this knowledge come from? And how did we lose it so completely that it took a statewide disaster for people to remember it? The answer goes back much further than Texas. It goes back further than America. It goes back to the oldest plumbing engineers in human history. The Romans were building sewer systems while most of the world was still using open trenches. Their aqueducts and drainage channels, some of which are still structurally intact today, nearly 2,000 years later, were maintained using something they had in almost unlimited supply: vinegar. Roman sanitation workers called aquarii used diluted acetic acid to flush sediment and organic buildup from clay conduits on a seasonal schedule. They did not understand the chemistry, but they understood the results. Pipes maintained with vinegar flushed ran clearer and lasted longer. That empirical knowledge was passed forward through medieval European guilds, into early colonial plumbing practice, and into the farmhouses and rural homes of 19th century America. Then, in 1791, a French chemist named Nicolas Leblanc developed an industrial process for producing sodium carbonate, soda ash, from common salt. For the first time in history, alkali compounds that had previously been expensive and rare became cheap enough for everyday domestic use. By the mid-1800s, baking soda, sodium bicarbonate, a refined derivative, was being produced at industrial scale and sold in general stores across Europe and North America. Farmers used it. Miners used it. Railroad workers used it for everything from cooking to cleaning to maintaining the washhouse drains at mining camps. There are documented accounts from Colorado mining settlements in the 1880s of camp managers writing procurement lists that included baking soda specifically for monthly drain maintenance, listed alongside soap and salt as a basic infrastructure necessity. This was not a home remedy. This was institutional knowledge. This was the maintenance protocol of people who could not afford for their systems to fail, living in places where the nearest plumber was 3 days away on horseback. And it worked for 100 years, until one product changed everything. In 1923, a man named Harry Drackett, a janitor working in Cincinnati, Ohio, discovered that combining lye with aluminum chips created a violent exothermic reaction powerful enough to burn through grease blockages. He patented the formula, named it Drano, and by 1930, it was generating millions in annual sales. Within a generation, the institutional memory of baking soda and vinegar maintenance had been replaced by a product, not because the product worked better, but because the product was marketed better. By 1970, The drain cleaning chemical market was worth hundreds of millions of dollars. By 2023, it had grown to over $3.2 billion annually in the United States alone. $3.2 billion. For a problem that a 40-cent solution prevents entirely. Here is the economics, stated plainly. The average American homeowner spends $280 per year on drain-related maintenance, chemical products, professional clearing, and emergency plumbing calls. That figure comes from home services industry data. Now multiply that by the 140 million households in this country. That is $39 billion per year flowing out of American homes and into an industry that exists, in large part, to solve a problem that should never exist at scale in the first place. An industry does not spend $14.7 million on lobbying between 2010 and 2020, which is the documented figure from Open Secret's federal disclosure records, because it is confident its products are the best option. It spends that money to make sure the question of whether there is a better option never becomes mainstream. That is not a conspiracy. That is standard market economics. And understanding it is the first step to opting out of it. But now we need to talk about science. Because the biggest mistake people make with the baking soda and vinegar method is not understanding why it works, which means they use it wrong and then conclude it doesn't work. Let's clear something up immediately. Most people think the fizzing reaction is the active ingredient. They see the foam, they think the foam is dissolving the clog, and when the clog comes back in a week, they assume the method failed. The fizz is not the mechanism. The fizz is a side effect. Here is what is actually happening in your drain. A household clog is almost never a single substance. It is a layered accumulation of three distinct materials, cooking grease and animal fat, which adhere to pipe walls like wax and harden over time. Biofilm, a bacterial colony composed of soap residue, dead skin cells, and organic matter that bonds chemically to the grease layer. And hair, which meshes into the biofilm and acts as a physical net that catches everything else. These three materials together can reduce your pipe's effective diameter by 40 to 60% before you notice any slowdown. Commercial drain cleaners attempt to address this with brute chemical force. Sodium hydroxide, Li, is the primary active ingredient in most products. It generates intense heat on contact with water and attempts to burn through the blockage. The problem, it does not discriminate. It burns the grease, yes, but it also begins degrading PVC pipe joints and fittings with repeated use. The American Society of Plumbing Engineers has documented this effect in technical guidance. Plastic pipes in homes older than 15 years are particularly vulnerable. The baking soda and vinegar method works differently. When sodium bicarbonate meets acetic acid, the active compound in white vinegar, they produce carbon dioxide gas, water, and sodium acetate. That CO2 foam does something clever. It physically agitates the biofilm layer, disrupting the bacterial colony's adhesion to the pipe wall. The sodium acetate that remains is a mild surfactant, meaning it reduces the surface tension that holds grease to the pipe surface. Then, and this is the step most people skip, the hot water flush completes the job. Water above 60 degrees Celsius liquefies cooking fat and carries the disrupted biofilm out of the pipe entirely. The fizz loosens. The surfactant releases. The hot water removes. 3 steps, 1 integrated process. And when heated vinegar is used, brought to approximately 85 degrees Celsius before application, the thermal energy dramatically accelerates the reaction, producing a foam capable of addressing blockages up to 2 meters deep in the pipe run. Documented household testing shows that this heated variation restores drain flow to 90 to 95% of original capacity in a single application on moderate blockages. Now let's talk about what the commercial products do to your pipes over time, because this is the section the drain cleaning industry really does not want you to see. Sodium hydroxide, the Li in Drano and similar products, generates temperatures exceeding 80 degrees Celsius on contact with standing water. In PVC pipes, which are now the standard in homes built after 1975, repeated exposure to these temperatures causes microfracturing in the joint seals. You will not see it happening. But over 5 to 10 years of regular use, those joints begin to weep. By the time you notice a leak behind the wall, the damage has been building for years. And the danger is not limited to pipes. Sodium hydroxide products, if they contact skin, cause chemical burns within seconds. Every year, emergency rooms across the country treat burns from drain cleaner splashback, overwhelmingly affecting children and elderly adults. The Centers for Disease Control has documented over 3,000 annual injuries attributable to household drain cleaning chemicals. Some homeowners, frustrated that lye products do not work fast enough, mix them with bleach. Or mix bleach with an ammonia-based cleaner to try to boost effectiveness. Bleach plus ammonia produces chloramine gas. In an enclosed bathroom, that gas can cause respiratory damage within minutes. This is not hypothetical. Poison control centers receive calls about this specific situation every week. The inexpensive method is not just cheaper. It is categorically safer. For your pipes, for your children, for your lungs. So here is exactly how to do this, broken down by the type of clog you are dealing with, because the protocol varies and precision matters. For kitchen drains, where cooking grease is the primary culprit, begin with the kettle. Boil a full liter of water and pour it down the drain in 3 stages, 30 seconds apart. This softens the hardened fat layer coating the pipe walls. Then pour half a cup, approximately 125 grams, of baking soda directly into the drain. Do not pour it on standing water, it needs to reach the pipe. Follow immediately with half a cup of white vinegar, heat it to just below boiling. Place a drain plug or a folded cloth over the opening. You are trapping the carbon dioxide foam inside the pipe, forcing it to work against the blockage rather than venting upward. Wait 45 minutes. Then flush with the hottest tap water you can produce, sustain for 2 full minutes. For bathroom drains, the approach is sequential. Hair is the dominant material, and no liquid dissolves hair. Begin with a physical snake, a $5 plastic drain snake from any hardware store. Insert it, rotate slowly, and withdraw. You will recover a mass of hair and soap scum. Do not be alarmed by how much comes out. Then apply the baking soda and vinegar protocol exactly as above. The chemical treatment dissolves the biofilm residue that the snake left behind, preventing rapid reaccumulation. For slow drains that are not yet fully blocked, the most common situation, a monthly maintenance routine prevents the problem from ever developing. On the same day each month, apply the basic protocol: baking soda, hot vinegar, 45-minute wait, hot water flush. Total time investment, 5 minutes. Annual materials cost, approximately $10.80. For complete blockages, no movement at all, begin with 2 full days of hot water flushing, twice daily. This softens the core of the blockage. Then apply the heated vinegar treatment. In 80 to 85% of complete residential blockages, 2 to 3 consecutive daily treatments will restore full flow without professional intervention. If flow does not restore after 3 treatments, the blockage may be in the main sewer line rather than the branch drain. At that point, a professional camera inspection is the appropriate next step, not a chemical treatment. Something happened in the 20th century that went far beyond plumbing. We allowed an entire category of practical knowledge, the accumulated maintenance wisdom of every culture that had ever built a drainage system, to be replaced by a product. Not because the product was better, not because the knowledge was wrong, but because the product could be packaged, distributed, and sold, and the knowledge could not. Every grandmother in San Antonio who walked next door in February 2021 carrying baking soda and vinegar was carrying something more than a drain cleaning solution. She was carrying 2,000 years of field-tested, empirically validated understanding of how organic matter behaves in confined spaces. She was carrying the institutional knowledge of Roman engineers, French chemists, Colorado miners, and generations of rural American families who understood that maintaining a system costs far less than repairing one. That knowledge was not lost by accident. It was replaced by a market, and the market will keep replacing it, for everything, not just drains, unless you choose differently. Here at Frontier Trapper, that choice is what we document. Every low-tech solution that works. Every piece of forgotten knowledge that the modern consumer economy has quietly buried under a product. If that matters to you, if you want to know what your grandparents knew that you were never taught, then subscribing is the simplest thing you can do to make sure the next discovery finds you. There is an ancient heating system I have been researching, one that uses the stable thermal mass of the earth beneath your foundation to maintain a comfortable indoor temperature year-round, with no fuel, no electricity, and no mechanical components that can fail. It was documented in Roman villas, refined by Korean engineers in the 14th century, and quietly suppressed in the 20th century because it cannot be metered or built. I have covered exactly that in this video. Make sure you have a look at it.